So what we have is that we have to discuss the convergence of this sequence, right? Make sense? So what we have is, so I have all these entered here, okay? So I would have 1 minus 2 divided by, of course, this cell here, right? Okay, and then times what? 4 times who? Again, the same cell, right? And of course, I get a 1 here, right? Okay, because that will be, okay. So let's see how it goes, okay? So here, does it appear to converge?
No.
Well, let's see. Okay, all right. Let's proceed further then, right? Okay, here stabilized pretty well, right? Okay, so
You are doing in Excel.
no, I have n, right? Okay, just a second. Yeah, I'm doing it in Excel, right?
It's easy to, yeah.
Right, exactly. And you can do it in as a table in your calculator, right? Okay, let's see here. Okay, does it appear that it should, I have, okay, 0.033 and all that. Okay, or we may go further down. Okay. Here we are, right? So 0.0033000033. Does it appear that it will converge, or we can check analytically later on? I mean, here you can see it looks like that it's going to what? 0.0003324, right? Makes sense? Okay, so if I have to check it analytically, I mean, it kind of a formality, but we may write that if we are letting n run to infinity and the limit is available, okay, so then in that case it has to be the same as what? If I change n by x, which is varying continuously along the real line, okay? All right? Okay, good. So now I have to find this limit, and this is of which form? 1 to the infinity form, right? Which is indeterminate, as you will see that, right? So it is this form, okay? All right. So I mean, in this case, you know, we have the problem in the exponent. It's generally a good idea to, let's replace this by another variable, okay? And then we will take natural logs, okay? All right. And then what we will do is that if I'm able to find, come in, Eric. Okay, if I'm able to find the limit, okay, then we will just exponentiate that. All right. Okay. So that's let me just stop this for a moment, introduce you guys to each. So what happens here is that I can, so when I'm taking the natural logs to simplify it, this 4x will do what? It'll just step down, right? Make sense? Okay. So now let's see what happens when we take the limit as x goes to infinity, okay? All right. So when we have this, okay, then here on this side, what we got this, okay? Now this is going to be what? X goes to infinity, right? And as x goes to infinity, 2 over x goes to 0, so this approaches natural log of 1, which will be 0. So this becomes what then? Infinity times 0 form, which is still is indeterminate, right? Okay. So now, so when you get infinity times 0 form, it's you may try to change it to 0 over 0 form or infinity over infinity form, right? So in this case, if I did infinity over infinity form, I have to take this to denominator, which will make it a little bit more complicated, right? Okay, so it'll be a good idea to take this factor to the denominator. So let's try that. Okay, so
Why we put them as a denominator?
Yeah, because see, the thing is, it's infinity times 0 form, and we can use L'Hopital, right, when we have either 0 over 0 form or infinity over infinity form, right? Okay, so what I'm doing is this now, that I am sending this factor here, and which you can see, if you simplify it, goes back to that, right? And now what we got then? We got ln of 1 is 0, right? And this also is what? 0. Now we have what? 0 over 0 form. Does it make sense? Good. So now when we have 0 over 0 form, what we can do is that we will go ahead and differentiate both the numerator and the denominator with respect to who? X. So if the limit is available, that will be our answer, right? Am I clear? Okay, so we have gotten this far, right? Okay, so let's compute these guys. Okay, so now go ahead.
So if we differentiate here without doing this, it will be same result.
Oh no, see, in order to apply L'Hopital, it has to be either in this form or infinity over infinity form, right? Okay, all right, good. Now let's differentiate this here. Okay, so when you differentiate a logarithm, say natural log of u, what's the derivative? 1 divided by, yeah, go, right, so 1 over 1, very nice. So it's 1 over, right? So this quantity, you said it correctly, right? And then I have to use the chain rule, right? So what would I have? The very good. You went a little fast on us, but that's very good. 2 over x squared is correct answer, right? Makes sense? Okay, I'll just write that in the next step. And this is what? Negative?
1 by 4x squared.
Okay, 1 over 4x squared. Just simple use of the power rule, right? Okay, are we good? Good. So, yeah, go ahead.
The 1 minus 2s should be
2 over x squared. Yeah, I know. I forgot that I am handling a calculus 2 class and I went awfully slow, right? Okay, looks better now, right? Are we good? Now what will happen? This x squared will cancel this x squared, right? Okay, and this 4 will join this 2 up here. This negative sign can be brought in front. So what shall we have then is let's write it in a simplified form, negative 8, because x squared is cancelled, right? Okay, times all that, right? So as x goes to infinity, the right hand side is simply what? Not 0. See, this goes to 0. So just modify your answer. It's like negative 8, right? Makes sense? Okay, so here we go. It's negative 8, right? Now our objective was to find the limit of y, right? So limit of y will be what? Its natural log has limit negative 8. So if I want the limit of y, I can just take exponentials, right, on both the sides. So this would be e to the what? Negative 8. Beautiful. Okay, are we clear? And who our y was to begin with? This guy, right? Okay, so I can have what? This is e to the negative 8, right? So the limit of the sequence is e to the negative 8, right? And that's what you saw, 0.033, right? It's 0.00033, and we could have gone further to realize that value. We are good so far here, right? Make sense? Okay, good. So that's how we can compute it analytically. Okay, so let's see. Say I have something like this. Now this is a sequence, right? Isn't it? Okay, and if if my n is ranging over positive integers, what will I have? 1 over 2, right? Then 1 over 4, then 1 over 8, right? Oops, sorry about that. Okay, 1 over 8, okay, 1 over 16, etc., etc., right? Am I clear on this? Yeah, I just wrote a few terms, right? And this sequence is a convergent sequence, right? And where does it converge to? It converges to what?
N value.
As n goes to infinity, the values go to what? Or in other words, who is the limit of 1 half to the power n as n goes to infinity? What is that? This limit is what? Okay. Yet what that limit will be?
1.
But well,
Infinity.
N is infinity, right? So 1 half to the infinity, what are we doing? I mean, the values are going on doing what? Look at this here, or we will go back to our spreadsheet. Okay. Okay, it does.
So it's going to 0.
It's going to 0, right? Are we good on this? It's going to 0. Are we clear?
One huge number divided.
Exactly. In the denominator we have a huge number, right? Okay. Am I making sense? I mean, are we okay? Now say we are doing this here. Say we have everything added. Say we are adding these guys. You can see instead of listing bunch of values, what we are doing now, we're just adding them all, right? Okay. All right. So now when we do that, then this is called a series. All right. Okay. So for instance, if I wanted to say express it in short like this, what I may do is that I can use the sigma notation, right? And we are starting from which power? N equals 1. And how far up are we going? We are going as far now. And then we got what? 1. Oh, let me just write it the original way. So this is a series, okay? And what we are doing in the series is that we are simply just adding the terms of the sequence, right? Are we good on this?
Yeah.
Okay. So now a question is this, that if we go on adding all these, okay, remember as you did in improper integrals, remember convergence of improper integrals, does this series converge, or as we just keep on adding and adding and adding these values along, okay, do we get to any finite sum, right? So what we would do is this, we will first use, so for, see how many terms do we have here? Tell me how many? 5 terms, right? So this guy would just do it like this, that I have 5 terms, right? And I can ask it that give me the sum. It tells me that the sum will be this, okay? Make sense? Okay. And if I did this, say if I wanted to get a sum of say 10 terms, right? Okay, then I can just change that to 10, and this gives me a sum of this, right? Okay, Now in your graphing calculator you can do it the same way, okay, like this. So for sequence, what we would do is this. Okay. We will enter our sequence here, okay. So we have, what are we going to enter here? Where are our parentheses? Are these the, yeah, these are the parentheses, right? And I'm just doing it exactly the way I had, right? To the power x, that's what I got, right? Makes sense. And well, we didn't have to, but I just cleared it out, okay. Now say if I wanted to do this, if I wanted to find this value, so this value is what? Let's look at this. We are doing what? We are taking sum of the sequence, okay, sum of the terms of the sequence, in other words, okay. All right, sum of the terms of the sequence, which sequence? This sequence right here, right? Makes sense, okay. All right, and what did we have here? Our n is going from where to where? 1 to how much? 10, right?
Yeah.
Good. So from 1 to 10. Okay. Good. Are we good on this? Right? So when we use the calculator, okay, then see, my sequence is like y1 here, right? Makes sense? Okay. So then I would do this. I should be able to find some sequence feature in here. I keep forgetting where we find this. No, we can't find it here. So let's go to math. Okay, math, right? I think it's in this one. No. Okay, let's see. Okay, I think it could be. No, it's not here, right?
I think it's second step.
Oh, second stat. You know it better. Thank you so much. Okay. Oh, very good, Eric. That's so kind of you. Here is sequence, right? And when we go to math, see, I forgot, and you remember, right? Very good. So this is, I am doing, oops, sorry, not there. Okay. Now let me see if I remember. Okay. So here we go to math, right? We want sum, right? We want sum of what? The sequence, right? So now I have to remember here again. Okay, so sequence is right here, right? And where is my sequence? My sequence is y1, right? So I can enter y1 directly here. So vars, right? Y vars. Okay, right? Say this is my sequence, comma, and instead of n, what I got here? I got x here, right? Then I'll say, well, add it from 1 to 10, and let's see if it gives us the same value, right? So what do we get? Yes, we do get the same value, right? Are we good on this? Okay. So now,
I didn't get the step. Calculator steps.
Right, it's okay, but I'm going to post it for you. So and I have many different videos that there are
step by step.
Right, exactly. So you can just
has y1. I didn't get
exactly.
it.
But the thing is, you just pause and just go like that. It will be up in very soon after we are done with this. Okay, very good. Now say we want to see how it would look like if I say added the first 100 terms. Okay, so here is
1 to 100.
right. It says, well, it stays at 1, right? Okay, well, I mean, that's how far this calculator could do. Let me see how far this guy can do it. Okay, so here, okay, So what you would say is that, well, it says that this is 1 here because it's just the best it could do, right? So you will say that series converges to what? 1, right? Am I making sense?
Yeah.
Okay, good. Let's look at more examples. Okay. So for instance, let me take a different series here. Okay, here, n equals 1. So now you see, tell me, it's a series or it's a sequence? What we have here, it's a series or a sequence?
Which one?
The one that I'm going to, oh, I'm sorry, yeah, it's a series, right? Very good. Okay, why don't you use your calculators, okay, and tell me, just go ahead and use your calculator and tell me that if I have this, okay, what will it converge to? Okay, all right. Now one thing, just look at this here. Say instead of 3/7, say I have 8/7 to the power n. Do you think this will converge? I mean, what we are doing is this. See, we are adding 8/7.
I don't think it will convert.
Yeah, numerator is bigger number.
Yeah, it will go on becoming bigger and bigger and bigger, right? So we have this. First of all, so say if I have a series like this, okay, so what we have is, for convergence of this series, we must have this, that is the limit as n goes to infinity, okay, of the of this nth term, okay, or the sequence formed by those terms must be 0, okay, because if this is not 0, then what's happening is kind of we are adding a non-zero number repeatedly with itself, right? Eventually. Am I making sense? So it will not converge, okay? So whenever you have a question that whether a series converges or it does not converge, the first thing to check will be to check whether the limit of this term is 0 or it is not 0, right? Am I making sense? Okay, so let's
So if it's 0, then it converges.
no, that's not necessary. We are going to see that. But if it is not 0, I know right there that it does not converge, okay? So here, let's just look at some examples, okay? Okay. So here, let's do this. Check the convergence. Okay. So let us examine this one. So in here, what we have is, as n goes to infinity, this will do what? This will go to cosine 0, which is what? 1, and which is what? Not equal to 0, right? So we can write exactly. So we can say right there that this series diverges. Okay? Am I clear? Okay. Now, but say if we have this, say instead of this I had sine of 1/n, right? Is that clear?
Yeah.
Okay. In here, what happens if I am looking at that? Then this will change to what? Sine, right? Which is sine of who? 0. And that is what? 0. does it guarantee that it converges? No, not doesn't. It may not. Okay, so it still have to do what? To examine whether this converges or this does not. Okay, all right. Am I clear? Okay, so now we will take this question up later. All right, so first let's just do this here. For, if I have a series like this, AR square, or let's say AR plus AR square plus AR cube, etc., etc. All right. Okay, say I have a series like this. Okay, now you can look into the lessons that I posted, that this converges to what? A over 1 minus R. Okay, very good. If and only if the absolute value of R is what? Less than 1, right? Otherwise it diverges. Okay.
Then I have a question.
Go ahead.
You were saying at the beginning that it has to be equal to 0.
The limit has to equal 0, yeah.
The limit has to be equal to 0.
Right, exactly. The limit has to equal 0.
Okay.
And when absolute value of R is less than 1, we had proved that the limit of R to the n will be 0, right?
What are we consider as R?
R is, okay, for example, say I have this 5, okay, minus 5 times, say 1/2, all right, with me, plus 5 times, say 1/2 squared, see that, minus 5 times, okay, 1/2 cubed, see that here, okay, and etc., etc. So it's going like this. So what is R here? Compare the two.
So this is changing,
So,
negative and positive.
Right, sign is changing. Right, so R is, yeah, go ahead.
R
Yeah,
is a coefficient.
R is this value here. Okay, let me just quickly, just 1 second, okay. Okay, so what R is then? Look at this here. See, first of all, I mean here we just made it like, I don't know, slightly tricky, whether, okay. So it's no, it's like 1/2, right? See this here, okay, but then the signs are alternating, right? So I have 1/2, and also I got like negative 1 to the power n, and then changes, it just changes between positive and negative. So my R will be what? Simply negative 1/2 here, right? Makes sense? Okay. So for this one I have this. So this series up, that we just took, it converges to what? 5 divided by 1 minus negative 1/2, right? Are we clear? Okay. So there we go, right? It converges to 10/3. Okay. So and likewise, say I have if instead of this, if instead of say 1/2, I had this, say 3/2 here, right? What happens here is that the absolute value of R is less than 1, right? In this case, what happens? The absolute value of R will be more than 1, right? So negative 3/2, that's 3/2, that's more than 1, and this series does what? It diverges, right? Okay, so keep
But this negative right? It's not cannot be greater than 1.
But I took the absolute value,
Oh,
right? See,
okay.
we are talking about the absolute values. Very good. Okay, yeah, very good point. Very nice. Okay, makes sense. So keep this in mind. You know, this is geometric series, and this is a very simple series. Okay, so this series that we have here is called the geometric series. Okay, am I clear? And of course here we are treating a as not 0, because if a is 0, then no matter who r is, right? Okay, so the thing is, we are treating a as non-zero. Okay, so are we good so far? Okay. So let's talk about other kinds of series, like, you know, we were looking at sine this series here. So go ahead.
We are discussing this 8.2, right?
Right, this is section 8.2. Yes. Okay, so we are talking about this, right? Very good, Paul. Thank you. So here, say I added it to 10 terms, right? Okay, let's see where it goes. It goes here, right? Say I added it to, say, 20 terms. Okay, well, became bigger, say 30 terms. All right, still it doesn't increase that fast, right? But it goes on doing what? It keeps on, oh, well, it's still increasing, right? Okay, so if we go like say 50, right, it's still increasing, right? Okay, let's go like a little big. Okay, right, now let me save it here, because this package is a little temperamental. Okay, all right, let's see. All right, it became bigger even, right?
This will be the next one.
Oh, well, let's see. Let's go 1,000. Okay, all right. No. All right, so let's go like, so when we are looking at bunch of values, right, it doesn't appear to converge, and very soon we will have like deductive ways of you know, settling this kind of a thing. Okay,
Just keep going.
okay, it keeps getting bigger and bigger, right? Okay, it doesn't get big that fast, but the thing is still, it's not staying within, you know, like, yeah, it's becoming bigger and bigger, right? So here we have an example which doesn't appear to converge. Whether it converges or it does not, I mean, we don't know yet, right? Okay, I mean, very likely it's diverging, right? But we will take up, you know, how to determine that, you know, using theorems or in a deductive fashion later. Okay, all right. Okay, so